Good afternoon. My name is Dr. Carlos Perez. We're going to talk a little bit about sports today. Let me introduce Dr. Jamie Tarter, Dr. Corey Peacock, and Dr. Jose Antonio. And Kristen, we're going to be in the back and let you do what you do. Welcome.
Thanks, Dr. Perez. Excuse me. First of all, I want to welcome everyone to this, let's call it a podcast, because we're going to keep this informal. We want the audience to learn a little bit about what we do, a little bit about myself, Dr. Tarter, Dr. Peacock. Again, the title of this is NeuroSports Go Ahead, Make My Brain, the marriage of neuroscience with exercise science. But first off, a little introduction. My name is Jose Antonio. I'm an associate professor in the Department of Health and Human Performance, and my primary area of research is in sports nutrition. And Dr. Tarter, a little bit about yourself.
Thank you. I am Dr. Jamie Tartar. I am the president of the Society for NeuroSports, and we'll be talking a lot about that today. I am a professor of neuroscience at Nova Southeastern University in the College of Psychology. My primary research areas are stress, sleep, and lately, sport neuroscience.
Very good. And last, I'm Dr. Corey Peacock. I'm the program director of exercise and sports science at Nova Southeastern University, an advisor to Dr. Tartar and the Society for Neurosports. And my main focus is kind of the exercise physiology, integration of all of the sort of specializations and disciplines that Dr. Tartar and Antonio have talked about in the world of mixed martial arts.
Now, before we start, first I want to make an announcement for our second conference, the Society for Neurosports. It will be held at Deerfield Beach at the Wyndham, March 26 and 27. So if you have an interest in this field, this is a great conference to go to. It will be both in person and also virtual. So you have the option of doing one or the other. However, I would suggest in person because it's on the beach and it is a beautiful venue. So just mark that in your calendar, March 26 and 27. Now, a little bit about how we started really combining two different fields, exercise science and neuroscience, because this isn't what you would see as a natural collaboration, because these are individuals in really almost polar opposite fields that rarely see each other. And the way we got started was actually, it was Dr. Jamie Tarter reaching out to myself. This was, seems like many years ago, to collaborate on a project with one of her students. And that kind of just snowballed into myself, Dr. Tarter, Dr. Peacock, eventually working on several projects in which we combined things related to exercise as well as things related to the brain, hence basically a new field that we call sports neuroscience. So first off, I guess let's start with some of the practical aspects about what we've learned in terms of combining these two fields. And this will be addressed to you, Dr. Tarter, in terms of, Dr. Corey Peacock and I, we're big fans of exercise. We love to work out. The people that we study are like highly trained people, but there's also a benefit to exercise for people who aren't even high-end athletes. So comment on that a little bit.
Sure. Yeah, thanks. And I put it in the chat. If anybody's interested in the conference, I know somebody just asked a question, you can head to our website, neurosports.net. And that's where you can find all the conference and registration information. Right. So as a neuroscientist, I think we know more and more, especially in the last 5 years, that if you want a healthy brain, you have to have a moving body. And these things are very closely related as we move. And that's an important thing that we want to talk about, as you just mentioned, because sometimes when I, as a non-exercise person, think of exercise and exercise for health, my brain immediately goes to like signing up for a marathon or doing something pretty incredible. And so when we say exercise and the benefits of exercise for the brain, we really want to clarify that what we really mean is you just need to move more. We know that the natural human condition, if we look at hunter-gatherer populations, they're moving about, over 2 hours, about 2.5 hours every day of moving. The average American doesn't usually move more than 30 minutes a day. Less than 5% of the American population moves more than 30 minutes a day. And so what we know is that when you exercise, when you move and you use your muscles, that you're going to release proteins and hormones. Proteins and hormones called osteocalcin and irisin, if you want to Google them, and BDNF in your brain. And all of these things you can really think of as really fertilizer for brain health. So just like growing a garden, right? This helps your brain to grow. It helps your neurons to stay healthy. So exercise, along with nutrition and sleep is probably one of the absolute best things you can do to have a healthy brain. And it gives you a nice butt too if you do it long enough.
Well, no, those actually, I think you touched on a lot of points. And like you said, people often confuse exercise with having to do something crazy like run a marathon. And in fact, according to, for instance, the American College of Sports Medicine, the amount of exercise you need to do just to improve general fitness is roughly 20 minutes 3 times a week, which, to be honest, that's 1 hour a week. That's hardly anything. Now, we deal with all sorts of different people, general population, as well as the elite athlete. And I think we need to sort of separate the two, because a lot of people see these high-end athletes and like, wow, I can't really do that. When in fact, just a little bit of exercise makes you feel better. And as you know, it makes your brain feel better. However, we're not really sure what it does in terms of making you feel better, but we know, you have lower rates of depression and things like that. But before you address that, Dr. Tartar, I want to go to Dr. Peacock, and because he works with super high-end athletes, I mean, professional fighters, and comment a little bit on how the field of sports neuroscience has shaped what you've done with these high-end athletes.
Sure. So as you alluded to, I'm fortunate to work sort of on the preparation side of a lot of very elite UFC fighters. Kamaru Usman, for instance, being the welterweight world champion. I've worked with him for 14 camps now, so it's been a heck of a journey. I think one thing, kind of to maybe hit two different points that both of you brought up. We're in this field where I'm reaching out to a lot of different professionals from all across the spectrum: physical therapists, occupational therapists, sports nutritionists, sports psychologists, neuroscientists, exercise scientists, strength and conditioning coaches. And I've found that particularly with mixed martial arts and probably a lot of the other contact sports, football, soccer, those kind of things, I think everybody does have a slight or maybe just a special interest in brain health, right? I mean, we're thinking about the success of these athletes now, but we're also thinking about longevity, healthy lifestyle, and all of those things that are going to be associated with these athletes as they sort of transition out of the sport and into the real world, back into the general population. So I think this idea of neuroscience and neurosports, particularly this conference, being sort of a hub for all of those different specializations to come in and share their information. It's a shame to me that athletic trainers that deal with this on a daily basis have their own separate conference. Exercise scientists have their own separate conferences, nutritionists, and so on and so forth. And so many practitioners are out here, and researchers and scientists, publishing all of this great research in the same area, but there hasn't been a localized conference for all of this to come together. So, that kind of my idea of why I love this idea of the NeuroSports conference and sort of this platform. And, to more specifically answer your question, having this platform and having this interaction with so many different specialists has really been able to enlighten, change, sort of impact the way that I am prescribing, programming, and working with these athletes on a daily, weekly, monthly basis, where it's kind of taken me out of this spectrum of what am I doing with them today, but really looking at them across the spectrum of their camp, their career, and transitioning into the real world. So it's just been a great experience for me, very informative. I'm one of those people that I'll openly admit, if there's something I don't know, I want to talk to the expert of this field and be able to find those things. And I think that this conference has really created a platform for that.
Actually, I wanted, in terms of mixed martial arts and athletes that really put themselves at risk, and I want Dr. Tartar to comment on this. We did really a series of studies where we looked at different athletes, former NFL football players, mixed martial arts athletes, as well as female soccer players, and that there is a risk to the brain in some of these sports. But it can be mitigated, perhaps. And I know there's some sports nutrition data on creatine, for instance, that might mitigate some of the effects on the brain. But comment a little bit on the idea and how we came about looking at these different athletes and how it might affect a brain function.
Yeah, well, I think it was interesting because, as you know, like Corey and I had talked about looking at brain health and some of his MMA fighters, and it was something that I think he had been thinking about, just being concerned about the health and well-being of his fighters. So we had that conversation, and then I'd met Julius randomly. Julius Thomas was a former NFL player. We had met at a talk, and we randomly started talking about brain health and NFL players and his interest in this space. And so it just seemed really coincidental that I had just been talking to Corey about this. I mentioned it to him, and he's like, "Oh, Corey Peacock, I know that guy. I randomly met him on a plane." So at that point, I think that study had to happen because it was just too serendipitous.
Well, I think that's the funny thing too, Jamie, when we're talking about that story, because that's kind of the same interaction I had with Julius. But I'm laughing because he was in Las Vegas for, I believe, maybe a NFL sort of event. I forget what he actually had out there. I think this was right when he just retired, and I was out there for a fight, and he and I both did the same exact thing. We both had enough of Vegas early, and we both changed our flight and ended up coincidentally on the same flight, sitting next to one another. And that was where that conversation came up, where he was talking about obviously brain health and those kind of things, and really put those ideas together. So I think it's like you said, it's one of those things that it really, really had to happen.
Right, and I'm so glad that we were able to cut across fields, because I don't think a lot of people recognize or really even know that most academics, as to Jose's earlier point, work in silos, and it's very rare for people in different fields to work together. And what was obvious to me, and I think to all of us, was that every time we talk, we come up with 100 different experiments that we need to do, because it's so obvious that these fields should be working together. So we did the study, and it's very, very close to being ready for submission, the larger study. We did see some interesting results. And what I thought was important about this work and what people might be interested in is, most of the time when we talk about brain health and contact sport athletes, we look at them at very specific times. Contact sport athletes, especially professional athletes, they're very well checked on while they're professional athletes. But then there's this long period of time where we don't really know what's happening to them. But then later on in life, we see that they're maybe starting to come up with, some cognitive impairments or some issues with emotional well-being. And we know that, as one of our good friends says, hitting your head is bad, but if hitting your head was the only thing that mattered, there would be a very direct relationship between the number of concussions and the outcome of those concussions in terms of neurodegenerative symptoms. And that's not what we see. And so we do find, like one of the studies that we just published, right? We see that women may be more at risk due to women are just smaller, like women soccer players, their skull isn't as thick. And we see that MMA fighters seem to be a little different young. So we're looking at young people, not when they're in their 60s and 70s, people when they're in their 20s, early 30s. So we see, especially in some of those inflammation markers, NFL players don't look like MMA fighters. They're showing a different inflammation profile. We see that in terms of some of their neurobehavioral and psychological health. NFL players look a little bit different, especially in anger and aggression measures, than MMA fighters. So we almost even need to think about not just how many times they've hit their head, but these unique experiences in the different sports and how that might be affecting them neurobehaviorally and how that may influence brain health down the road. So I'm really excited that we were able to do that. And we were just emailing this morning, and hopefully we'll be able to follow up on that with some follow-up work on pain, especially.
And actually on that same point, we parceled out some of the data, as you remember, on some of the female soccer players. And these are young women, ages 18 to 21. And we know that among soccer players, women tend to get more, female soccer players tend to get more concussions than males. They tend to get more, brain injury. And we looked at a protein, neurofilament light, and we found that, at least in this very small cohort of female collegiate soccer players, it was significantly higher than women who were also very well trained but didn't participate in a contact sport. So I know this is really a speculative question, but what does that mean if you're that young, right? And you're playing, and most of these women have been playing soccer. They were probably playing travel soccer since they were little. So it's not like they came to college and like, oh, I think I'll play soccer because I'm athletic. They've already been doing this since they were little kids. speculate a little. What would be the effects of doing that for literally a decade or two on possible brain health? And actually, you can even segue to that in terms of playing football, because Dr. Peacock played football in college. Is there something that might happen when Dr. Peacock turns 40?
Yeah, I think I'm hesitant to speculate because I think, the answer is we just don't know, because I do think we need more studies like this that show these biomarkers that we know are associated with poor brain health when people are experiencing neurodegenerative diseases. What does that mean in the short term? And I think the race is on, right, to look for acute biomarkers of concussion. And I know that there's some that just came out with varying degrees of sort of confidence in these measures. But I think we really just don't know what these acute increases mean, or increases when you're young, and what the effect will be later on in life. Because I think it hasn't been that long that we've been really looking at these things. So I think it's one of those time will tell phenomena. But I think it's alarming to me that we saw that in women, because I think when we think about brain injury in sport, we don't think about female soccer players. We think about maybe male NFL players. And I think one of the ideas is that even relative to male soccer players, the fact that females, basic sexual dimorphism, females are just smaller than men. So them getting hit in the head just with their neck musculature is going to be a much greater insult than it is to men. But I do want to mention that at the NeuroSports Conference, as you know, we do have some speakers who are experts in this field. We have Joseph Clark and Kester Ned at University of Miami, Matt Antonucci, who are going to come and talk about rehab strategies. So some of the good news, what you can do if you're an athlete who is getting concussion, the role of concussion in sports, and just training the brain with brain injury. So I don't want to be too doom and gloom that it looks like at our conference we may be getting some good news hot off the press.
Sure. And as I'm here approaching 40, I'd like to not jinx this this transition, as my head feels healthy as can be. But I think I'd kind of change the topic a little bit and kind of just inform the participants on some of the other research we're doing. We've also been able to kind of take some of this data and some of this profiling and look at certain genetic markers that are associated with dopamine regulation, abilities to perform under stress, particularly the COMT gene, or what people may know as the warrior gene. This idea that when we look at sort of the genetics associated with certain groups of athletes, particularly the mixed martial arts fighters, that they were actually significantly more, I don't want to say the chicken or the egg, I don't know if this is the disposition and why they picked fighting or what the case is, but we saw a significant higher amount of mixed martial artists with the warrior genotype as opposed to the other athletes. So again, thinking about that and looking at sort of how these athletes respond to stress, regulate dopamine under stressful situations, and those kind of things, I think that's an interesting shift as well with all of this data that we've been able to collect so far.
Yeah, I mean, I couldn't agree more, especially given that we even looked at the epigenetic effects in your MMA fighters, and the idea that we do see differential expression of some of these little microRNAs that help to regulate which genes are expressed and which proteins are ultimately created. And so I think, to Jose's point, when we think about the effects of these environmental insults and the proteins that may be expressed as a consequence to that, we really have to think of that, what we would consider an epigenetic landscape, that genetic by environment sort of relationship, where you almost imagine like that little ball on some landscape, but as the environment changes, your sort of genetic expression within that environment sort of feed back on each other. So they both matter, right? Genes and environment. So that's an excellent point.
I'd like to address a little bit, we've been talking about exercise and how great it is for the brain, but also nutrition. And we can address sleep because we know Dr. Tarter loves talking about sleep. But there is a nutrition component to this, and I'll be really specific. Many of you have probably heard of the dietary supplement called creatine. The primary form that you could purchase it, whether it's at Amazon, GNC, or whatnot, is creatine monohydrate. And if we go back, I think even if you go back a couple decades, there was some interesting data showing that creatine decreased or ameliorated some of the symptoms of traumatic brain injury in as young as infants up to 18 years of age. And we recently, we collaborated on a project, which included Dr. Jonathan Banks in psychology, looking at the effects of creatine on just basic cognitive function, and showing that it could actually help people. Oddly enough, people who tended to not train as much, sort of more untrained people, benefited from it more. So I want both of you to comment a little bit about that, because from a sports standpoint, we already, Dr. Peacock knows we've been suggesting creatine since the 1990s. But from a brain science, sports neuroscience point of view, Dr. Tarter, what are your thoughts on that?
I think that I know that, our good friend Scott Forbes gave a talk on this last year, and I follow his work closely. I think it is a pretty amazing nutritional supplement for overall brain health. And I just want to say that we have no financial interest in creatine. We're not.
Although I love creatine.
For me as a neuroscientist, I only take 2 supplements, and that's one of the 2 that I take. Your brain just doesn't get enough. Your brain doesn't get as much creatine as it could possibly use for overall health benefits. So I think it's a fantastic supplement. Although I'm such a big baby, I have to take the chewables because I don't like swallowing the pill or the powder. So like a child, if it doesn't come in gummy form or chewable form, I won't take it.
Well, I'm a fan of the capsules, to be honest. It's just easier to consume. In fact,
you're such a boy.
I've been taking creatine on and off. Well, actually, mostly on since Bill Clinton was president. I don't know if you guys can think that far back, but it's been a long time.
Yeah,
Dr. Peacock?
I'll say the other supplement I take, because something else is melatonin, but we can talk about that later.
Yeah. Okay. So my take on creatine, obviously, in my specific field, really 2 rationales for it. The performance side of it, obviously the energy system producing ATP, but more importantly for my individuals, it is that brain health. There are a lot of studies out there that have shown that creatine can protect from ischemic cell damage and different things like that, structural damage that affects brain cells. So I think there's a lot of evidence out there to support this idea of what I want to call protection for our athletes. More interestingly, I find with something like creatine, even when you look at sort of the origins of creatine research, I did a lot of work in a Parkinson's disease lab, so a lot of reading up on this. There were a lot of studies, decades ago, where creatine was actually being utilized. Dr. Antonio, you sort of mentioned that age group, that younger age group, but they were actually utilizing creatine with those younger populations that were actually developing sort of signs and symptoms and traits of certain neurological disorders like Parkinson's and MS and things like that, sort of this early onset emergence that occurred years ago. So I think it's extremely interesting. And obviously, yeah, I take creatine. Well, I should take it more, but I'm one of those people that if I don't get on a routine or I miss a workout, I'm not going to take it. So I'm just not, I should be better, but yes, I've been taking creatine, for years.
Yeah, I'll give you some of my chewables.
Yeah, I see somebody looking for milligrams of creatine. I would always just recommend about 5 to 6 grams of creatine per day. I think that's pretty adequate in my case.
2 weeks, right, to load. 5 grams a day for 2 weeks is the loading window.
Dr. Antonio, I'll let you take that one.
Yeah, loading. If you really want to load, it's 5 grams 4 times a day. So that's 20 grams a day for about a week.
Mm-hmm.
I've never loaded, mainly because I've been taking it forever. So the easiest thing to do is just take 5 grams a day and do it every day. So I don't know how many chewables you got to do, Dr. Tarter, to achieve.
It's a 5-gram chewable.
Okay. That's actually pretty good, a 5-gram chewable. So yeah, and we've done. We got creatine research going back really 30 years.
Someone's asking about teenagers. What about teens?
Oh, actually, I was going to address that. One, there's plenty of safety data on it. People have been on creatine for 20 years, actually, with no untoward effects. I'll address the teenage issue, both from a personal level and a scientific level. My wife and I used to coach travel softball. Both of my kids, I have twin daughters that are now juniors in college, but they played travel softball. We actually had probably one of the best teams in the country, a few times ranked #1 in the nation. And we had our kids taking creatine when they were little. When I say little, between ages of 6 and 11. It definitely can help performance because it helps with recovery. It helps power output. Anything related to speed and power, it will help. So for teenagers, I put my money where my mouth is. It's certainly safe, and there's plenty of data. Not as much as adults, but there's plenty of data to show that when you're taking creatine chronically, that there literally are no side effects, whether it's issues with the kidney, issues with the liver, because these come up chronically or constantly. It doesn't cause cramps. It doesn't help you put on body fat. Oddly enough, the best foods to eat to get a lot of creatine are fish. I mean, so for people, I always tell people, if you're anti-creatine, then you would be anti-fish, because fish, particularly herring, which I'm not a fan of eating herring, has fairly high concentrations of creatine. So if you're a fish eater, you're actually getting quite a bit of creatine. The individuals who don't get enough creatine are vegans and vegetarians, because creatine is present in meat only. So fish, beef, fish and beef would be
especially.
Yeah, red meat. But you'd have to eat a lot of red meat. You wouldn't have to eat as much fish, but I have friends who literally will not eat fish ever. They won't touch it. So they have to they have to supplement with it. Whereas I love fish and I'll take creatine anyway. So yeah, it's certainly very safe. And I'm a big fan of recommending creatine really to athletes of all ages. And I know the best effects are found in those who train. But even if you don't train, you should take it for brain health. And let's face it, it's hard for Dr. Peacock to admit this, but the most important part of our bodies is our brain. Not our pretty muscles, right?
Yeah, and it sort of all regresses back to this idea of, like we talk about, if you have good exercise, good nutrition, good sleep, you'll live forever, whether you want to or not.
That's right.
Yeah, somebody had asked, I think we had gone over that at the beginning. She was having trouble having her patients do basic exercise, but we did say in the beginning, just 30 minutes of exercise. Dr. Gomez Osman, who's at University of Miami, she was a speaker at last year's NeuroSports, and she talks about exercise dosing for Alzheimer's. For young or old people, especially older adults, exercise should definitely be a prescription to sort of guard against neurodegenerative diseases and help with Alzheimer's. So everyone's got to move.
Now, there's a question here, which is interesting, about taking creatine immediately post-concussion. And I know, well, actually, I don't think, and you guys can correct me, I don't think there's any data on that at all that I'm aware of.
No, I think all the studies I'm thinking of are long-term use. But
It's not.
You can send an email and he'll look it up for you.
Yeah, I think, like, for instance, you see it in football a lot. Actually, you see it in mixed martial arts or boxing. If someone gets knocked out, clearly it's a concussion. Corey, Dr. Peacock, do coaches ever say, hey, you know what, you got knocked out, you got to take a few months off per protocol for, UFC? Do they have a stance on having them take creatine, post-concussion?
Yeah, I would say there's definitely two trends that you're going to see over there. You're going to see creatine supplementation, and you're going to see a high fish oil content as well. Those are typically the two things that I would say our athletic training practitioners, our nutritionists are going to push on our athletes during that period.
Yeah, I think that's good for even athletes that are in non-contact sports. Another supplement or food would be the omega-3 fatty acids. There is some interesting data showing that could also help with issues related to the brain. To me, creatine, the omega-3 fats would be two of the best supplements that could help the brain. There are others.
Talk on this at NeuroSports. You should promote your own talk.
Well, I've always been a big fan of creatine and secondarily protein. It's funny. Some of my students have said that it seems like my goal is to make sure all the students that come through my classes take creatine and protein. So it's just kind of interesting that, and it is a true perception. I try to promote that quite a bit. Now, this question came across that actually we've addressed, but I will talk about it again, whether you can take a creatine supplement for kids and teens. There's data on teenagers. There's even data on infants who have an inborn error of metabolism where they don't make enough creatine, because creatine is is a substrate used by the brain, and they've given gargantuan doses to infants just to normalize brain health. So it's safe for infants. It's safe for teenagers. I think there's even data, and I haven't looked at it lately, but there may even be data on pregnant moms taking creatine. But I'd have to go back in the literature to look that up. Oddly enough, I never get asked by pregnant moms if they should take creatine. So, but you never know, might get asked. So I figured I'd sort of throw that out there. Dr. Tartar, comments on anything?
I think we covered it. I think if people want to know, we do have a session at NeuroSports called Sports Supplements Good for the Noggin. So we'll talk about caffeine. We're going to talk about energy drinks, sports nutrition for e-gamers, which is interesting. So we'll have all of our experts there to talk about all of these different topics, and you can harass them with all your nutrition questions.
Yeah, talk a little bit briefly about the study we're doing on e-gamers, because I think that's interesting to a lot of people who aren't sort of traditional hardcore exercisers.
Yeah, it is interesting. And so we think of exercise as being good for the brain. Like we've talked a lot about, maybe we can circle back to that too, because we've also shown directly using EEG measures, some of the mood changes that happen with exercise, being positive and wonderful. So this idea with e-gamers is, whether you think they're athletes or you don't think they're athletes, you could probably consider them very similar to fighter pilots. There's a lot of cognitive activity happening when they're e-gaming. And so we really interested in looking at, does caffeine improve performance in e-gamers? Do other supplements like creatine improve performance in e-gamers? And one of the things that we are specifically looking at is, we think of, and I don't want all the parents to get mad at me because I have a 14-year-old son and he games way too much. But we think of, sometimes our kids are gaming, we don't think much is happening, but there is some research to suggest that there may be some neuroplasticity happening that's beneficial, especially beneficial for attention processes. So we're giving them lots of these attention tasks, these neurobehavioral tasks, and we're actually measuring their EEG, their brain activity. And one of the things that we can find out is how much brain activity are these e-gamers using when they're doing these really complex attention tasks. We can eventually compare that back to non-gamers. And then we can look and see, if you're an e-gamer, does it have the same, what we would consider ergogenic effects that it has in non-gamers? One of the benefits of caffeine is increased attention, especially short-term increases in attention. So we're really excited about that, and looking, like what Dr. Peacock had alluded to earlier, looking at some genetic polymorphisms that may influence attention and performance in this group.
What you alluded to, and I think I even had this impression about e-gamers, because I honestly, before we started the study, I honestly didn't know a single e-gamer, but apparently there are like thousands of them. They're everywhere. It's like, oh wow, this is really a popular thing. And there is a corollary in sports, and I'd like Dr. Peacock to comment on this, where there are sports that require quite a bit of, I guess, attention, focus. I guess that's the word a lot of coaches use. Race car driving is one. Hitting a golf ball, probably first or second hardest skill in sports. Pitching, so pitching, hitting a baseball, pitching. And even in the mixed martial arts, if you're in a fight, the wild card is the person in front of you, because you're not really sure how they're going to respond. So you have to have this sense of focus that I think e-gamers, they have to have, because they're constantly, they're e-gaming against other people. So the idea of sustained attention is critical, but I think oftentimes it isn't addressed per se by coaching. So Dr. Peacock, if you could expand on that a little.
Yeah, I think interesting enough, kind of a little, me, I get sidetracked a little bit. A good friend of ours, somebody I've worked with for many years, Chris Algieri. He's a professional fighter. He's a former world boxing champion, former world kickboxing champion, currently still fighting. A sort of a rare situation where he's a current professional athlete, but also has a master's degree in sports nutrition, has worked as a sports nutritionist for Division I collegiate athletic program. Well, all teams within that program. I don't remember if he's currently writing a chapter or consulting on a chapter, but he's actually doing a textbook for a textbook on this e-gaming topic and sports nutrition for that. And sustained attention and supplementation and things like that were definitely one of the topics that he and I talked a lot about when he was sort of formulating his ideas and putting these things together. But I completely agree with you. It's one of those things that I think with sustained attention and things like that, it's something that, it's an aspect that a lot of people aren't, I don't want to say quote unquote training, but I do believe if you are sparring and you are having jabs thrown at your head and you are doing those things on a daily basis for your MMA training, then this has to be something that you are somewhat training in just the natural aspect of the sport. But again, I think we see things that, when somebody loses that little grasp of attention, that's where injuries occur. That's where, even when I think of the sport of football, that's where I think a lot of concussions occur. I don't find it that two people that have fully sustained attention moving at full speed, I don't usually see that's the case where a lot of these concussions happen. It's typically where one person, full attention, 100% speed, and somebody else isn't paying attention and isn't at 100% speed, where a lot of those injuries occur.
Well,
I think that's exactly what they found too in the e-gamers, that they have better functional connectivity between attention networks and sensory motor networks. I mean, that's the benefit.
what about this sort of a pragmatic question that addresses some of that that strength and conditioning coaches or sport coaches could do? For instance, you mentioned, let's say, the fourth quarter in football, maybe a pitcher in the seventh inning, the fifth round of a mixed martial arts fight. You're oftentimes just suffering from central nervous system fatigue.
Mm-hmm.
What if you did this in training? You actually pre-fatigue them with some with a task that is very neurally challenging, right? Whatever that task is. Hell, they could do the psychomotor vigilance task, which is very tiring for my old brain. I mean, I think I last like 1 minute before I'm like, okay, I'm done. But if you presented with a task that taxes the brain and then put them in a sparring situation where their body actually isn't fatigued, but their brain is, and they're forced to compensate in some fashion so that it's almost like you're training them to be alert. And I know nobody does this, but it's sort of something I've thought of. And so I guess this is more of a speculative question.
I don't know. I don't know necessarily that I have the answer, because like you said, it's not something that I see frequently done. The one thing that I will say that I feel our coaching staff, the athletes that I sort of work with on a daily basis, a lot of the things that we do are routine. A lot of the things that we are forcing them to do are things that we're going to have them doing during the fight. So there's going to be times when we allow them to sit on the stool earlier on, and we're going to force them to stand, kind of that idea of when you need it and those kind of things. Even with training and things like that, a lot of what we're trying to do is replicate certain incidences that are going to occur in the fight, whether that be cues from the coaches and timing in which our athletes are going to be sort of, where we're going to implement certain aspects of the game plan. But, it's a good idea, but again, it's something that I'm not seeing quite a bit.
Okay, what I'd like to do now is sort of switch a little. There's a question for you, Dr. Tarter, and then we're going to wrap this up. And again, tell the audience a little bit about our conference coming up. So there's a question for you, Dr. Tarter.
Sure. So we do EEG, but we're the other direction. So we look at the effect of some type of intervention on EEG, and that was actually, so I've been doing EEG for about 20 years. A lot of ERP research. And so that was actually the first study we did together, which is really, I think it's really sexy. So we actually had, because we talk a lot about, because we said, oh, nobody wants to train for a marathon. It's so boring. Like nobody wants to feel like you have to exercise for 6 months to get these effects. But the cool thing is that the effects of exercise on mood are almost instantaneous. So you don't have to wait. It's not like having to wait to get big biceps, right? Which I'll never get. So we had people just come into the lab, and the same people, randomized. 1 week they'd run on a treadmill. 1 week they would just stand there for 30 minutes. And we asked them about their mood, significantly improved mood, which is great. But then we don't want to just talk to them. We want to look at their brain. And so we showed them pictures of horrible things, really bad pictures, burn things and really scary pictures. And then some neutral pictures like coffee cups and pencils. And actually what we found is just that 30 minutes of exercise improved their self-reported mood. They felt better, but then their brains at a very deep level, deep in the limbic system, where you're not even consciously aware of that activity, their brain was inoculated against those negative images. So, even just short-term mood boost, short-term effects we know it has long-term effects on depression and anxiety, and it's beneficial for that. But it's nice to know that just a 1 mile jog in the morning, Carlos, is good enough to boost your mood.
No, and that's true. There's a lot of evidence out there supporting regular exercisers having decreased episodes of depression and anxiety. The majority of that research exists a little bit more in sort of long distance aerobics, cyclical type exercise, cycle, running, things like that. But there's also a sort of a emerging amount of research showing the same thing for anaerobic training, such as weight training and things like that as well. Not as much yet at this point in time. I've noticed there's a lot on the side of kind of referring to mental health, depression, and things like that. Obviously, it's a little bit out of my wheelhouse. But Dr. Tartar, could you sort of highlight maybe a few of the speakers or what we have that would be in sort of that area of mental health? I don't want to put you on the spot. You may have to pull up the agenda, but at least we could inform them about kind of who will be presenting at the conference that may be able to answer some of the questions that I've seen on the right-hand side a little bit better.
Sure. Yeah, I pulled it up ahead of time because I don't exercise to look better. I exercise from my memory as I get older. So I anticipated that I have to look up some of this stuff. So we did talk about the nutrition and brain health and brain injury. But we have so our keynote speaker is going to talk about the astonishing effects of exercise on your brain. Wendy Suzuki. He's just one of the most remarkable TED Talks out there. And Dr. Van Praag and friends are going to talk about neuroplasticity. So when you exercise, how does your brain actually physically change? It turns out it does, and it's good news. We're going to talk about sleep, right? Sleep is one of the best ergogenic aids you could possibly have for performance and just overall health. So we're going to do a session on breath in the brain, and the physical therapist is actually going to lead us through some breathing exercises to help with the nervous system and nervous system health. So I'm going to pay close attention to that one. We're going to look at a whole session on cognition, mood, and performance with some cognitive psychologists. So sleep and recovery and mood processing, sleep and memory. And then one of the last sessions is going to be, which I'm really excited about, mind-body approaches to exercise. So this idea of the moving mind and body cognition, how you can enter flow states and how that might be able to help with brain health. So there's a bunch of scientists from University of Miami who will be presenting that. So I think just seeing the overview of topics at NeuroSports, you can see given that it's a new field and this is the first academic society, you can really see the breadth of the topics that come into this and really the interdisciplinary nature of it all.
And to top it off, sort of to wrap this up, you'll meet a lot of very interesting people because the backgrounds can be so different. People who have done pure exercise work, people who've done neuroscience work, getting everyone together actually is quite a bit of fun. So just make sure you mark on your calendar. That is March 26 and 27 in Deerfield Beach. It is at the Wyndham. The Wyndham Hotel is right on the beach. It's beautiful view. Show up in person. The website is neurosports.net. That is neurosports.net. And we are hoping, Dr. Tartar, Dr. Peacock, and myself, that you show up. And it's not a boring science conference. It's actually a lot of fun. So I want to thank, that's right. So I want to thank everyone for spending this lunch hour with us, and make sure you get your protein and creatine and your fish oil. It's good for the brain. Thank you.
I'm definitely going to go get a little creatine and get back on my push-ups. So the conference is not only in Deerfield Beach, but they can sign on through through Zoom as well, correct?
Right. It's a
Yes.
hybrid conference. It's going to be everything's going to be virtual as well as in person. And Dr. Perez will actually be there helping us with the virtual part, so we can party with Dr. Perez some more.
And Julius Thomas, who's a clinical psychology student, will be our, what's his official role?
He is your web host, and so he really wants to make it, and we want to make it really engaging for the virtual audience. So we have 10-minute breaks, and he really is going to use that time to interview the speakers, address questions. So we want, our intention and our goal, and I think we'll manage that, is to really bring the virtual audience into the conference so that they're not just passive, and they can sort of be part of the conference. And that's his, he's got a big job, but he's a big guy. He can handle it.
And Kristen, we have a few students that are interested in neuropsych and this specific issue as well, right? Help me promote it with our students. And thank you all for joining us. In case you didn't know, NSU, our main campus is here in Fort Lauderdale-Davie. We've got the College of Psychology, which has a number of clinics. There's also the sports psychology clinic here, and quite a few others. So definitely check us out at www.psychology.nova.edu. Thank you all for joining.
Thank you.
Thank you.